quick trivia. So name the deep-sea robot that recovered artifacts from a shipwreck and was able to explore a volcano. If you think it is A, OceanOne, please applaud. Okay, good. If you think it is B, SwimBot, please applaud. Uh-oh, you guys might already. If you think it is C, Find, Inspect, Search, Handle, Fish, please applaud. All right, so I think the audience thinks it is A. Let's see what the answer is. Yes, OceanOne. Good job, everyone. You seem to have done your homework. So you will be hearing more about OceanOne in our next talk. So I want to bring up Professor Oussama Khatib. Oussama is a professor of computer science here at Stanford and is the faculty director of the Stanford Robotics Center. And so Stanford Robotics Center shares HAI's commitment to ensure that interdisciplinary voices are involved in the conversation as we develop this technology. And I will welcome Oussama up here. And I will say just as working with Oussama over the past few years, he's an incredibly warm individual, and I encourage all of you to check out his center.
Thank you. Thank you so much. Well, everyone knows OceanOne, apparently, almost everyone. So actually, I'm going to talk about the excitement we have with a new initiative, the initiative of bringing yet more robotic effort at Stanford. And this is through the Stanford Robotics Center. The Stanford Robotics Center is actually a place very close to HAI. HAI is in Gates. If we look at the reflection of Gates, we will find it on a new building, basically the David Packer Electrical Engineering Building, and that's where we have now SRC, the Stanford Robotics Center. We are very lucky to be very close. In fact, we are close, much closer in our collaboration and research with the HAI. And the thing about the new center, it is not an extension of our laboratories. It's a concept that brings collaboration between different faculty in different areas of robotics to work in big challenges. So the team is quite impressive. It covers most of engineering school, medical school, sustainability school, and it brings really all the leaders in robotics who have been contributing to different aspects of robotics, and not in one research area, but from the design to the sensing to the users, and all of these faculty and their students and researchers came together to take on this challenge of developing this concept of the Stanford Robotics Center. So they bring knowledge in different areas. They bring different embodiments through designs of different robot systems and different component of those systems to achieve different interactions with the world among robots and to make that impact in the world and on humans. So in November 1st, we had a big launch, and the launch was an event that started in HAI, walking from HAI to SRC was guided by a robot, and here we see the robot guiding the
Robotics Center idea is really about how can we bring an environment for collaboration.
mate. So much of the work brings students from the different labs to work on challenges. So in the example of human motion, we are looking at how we can, from motion capture, take human motion, map it to a musculoskeletal model, extract from the model the feature of that motion, and map it to a humanoid robots. Well, this is an interesting analysis that brings comparison between the energy spent by human and the energy spent by or the robot. And of course, the answer is human is much more efficient. But then we started to see how we can use this to help improve performance, to help injured athletes, and to deal with many aspects of connecting human motion with robotic motions. Here in domestic robotics, we are looking at many different aspects of language communication with robots to deliver, to perform in a kitchen. And this is a project that is conducted in collaboration with Karlsruhe Institute of Technology. You saw the work that is being done in folding, the work that is done in a human environment, assistive robotics, human-robot interaction through a virtual environment. A very important aspect of robotics is the sensing. And in grasping, without really the tactile feedback, it's very, very difficult to do the accurate things in hand manipulation. And there is a very important work going on in developing further tactile perception and integrating it in grasping. Medical robotics is another area of interest that is really bring huge, huge implications in healthcare, and technologies and new concepts are bringing solutions that we couldn't imagine. This little tiny robot is able to be moving in the human body through magnetic field and performing operation in the human brain without having to open anything. We inject the robot in the bloodstream, and the robot is going to be able to navigate through the human body. This is done with a robot. A robot is guiding the motion, and this robot is controlled by a haptic device, something we didn't talk about yet today, which is the interface between human and the machine. This interface is very important. We see here the example in the area of ultrasound imaging. Ultrasound imaging is very challenging because sonographs hurt themselves very quickly, and by providing an interface like a haptic interface, the task is easier. However, it's not only about making the task easier, it is about how we are able to separate where the sonograph is and where the patient is. So this is how this is operated. The scanning is done by remote interaction with the robot through the haptic device. And now we have a control room through which we can control robots almost anywhere in the world. So from Stanford, we were controlling these robots at NUS, in Singapore, in South Korea, in Germany at DLR. And you see here the robot first at Stanford. So the robot is operated by a haptic device. The robot has all its autonomy, and the haptic is communicating with the robot remotely, and the robot is performing the ultrasound imaging. So now remote touching, and this is here in Singapore. And next in South Korea. And there is a humanoid robot, of course, at DLR. So humanoid robots are, and then all the robots are controlled at once with the same haptic device. So this was actually done in a reverse way at the last major conference in robotics called IROS. And from Abu Dhabi, we were controlling robots at Stanford, then at South Korea, at those labs, our colleagues and collaborator labs, and then we controlled all of them at once. So this was a remarkable achievement. It's not only seeing interaction, it is touching interaction. So being able to feel the contact and perform those interaction is really remarkable. This same method was used recently to operate from the east of China to the west of China with the same algorithm and same robots. So this was applied to OceanOne, and let me show you a few images of OceanOne in the Mediterranean. So here is OceanOne.
OceanOne-K, a unique underwater robot capable of carrying out archaeological excavations several hundred meters beneath the sea. Since 2015, an American team has been developing this revolutionary humanoid. The objective is to be able to explore shipwrecks, handle relics, evaluate and study treasures with the same precision as archaeologists.
Today, robots are designed to see, but we need robots that are designed to do.
This record would enable archaeologists to excavate countless wrecks of warships, merchant ships, aircraft, and submarines from every era that have up until now been totally inaccessible. But how can we be sure that OceanOne will withstand the extreme pressures? Or that its bionic hands will be able to recover sunken objects from the abyss?
So this work went through a number of steps, going from 40 meters and going all the way to 1,000 meters, which is quite challenging. 100 times atmospheric pressure. How you build a robot that can sustain that pressure, but also how can you build this dexterous arm to be lightweight and safe for interaction, and at the same time being able to go very, very deep. So the applications of robotics in the ocean are amazing. I mean, we know all the challenges we have with the corals, but archaeology is really pressing today because of the fisheries are going deeper and deeper. They are destroying everything that was left in the deep sea. And there are so many lost histories that we are seeing there. There are so many structures underwater that need not only to be monitored, but to really to be serviced. And to be serviced, that requires manipulation and actuation that is not today available, so that divers are still performing those tasks. Marine biology is a huge application area that is going to require also a lot of intervention of divers that are not there. Divers can go 50, 60, 100 meters, probably with a mixture of gases, but the ocean average depth is 3,000 meters, and we have nothing really to operate underwater. So again, pollution and the plastic, and there is mining. There are so many things. So reaching the deep is going to require the design of new concept for robotics. System that can navigate, go in the water. It's not going to be one robot, it's going to be a team of robots carrying those tasks. And then we need also the design of interfaces that are proper to those operations. And you need also to carry this with from the control room. So the control room here is showing the interface, which is the haptic device. You need bimanual haptic devices. You need to see in stereo. You cannot operate without looking and seeing in depth. So that requires display. So basically what you are seeing is what the robot eyes are seeing. And what you are touching is what the robot hands are touching. You are basically sending your eyes and hands through the robot, and this is becoming your avatar. You forget about the robot. You only see the hands and the eyes. And I mean, you see the environment behind the hands. And then you operate. The robot is autonomous, and the robot can operate on its own, but in those challenging unstructured environment, you need the human to be there. You need the surgeon to be there. You need the connection with the human. And this is the strategies that we are implementing here. In Aleria, a 2,000-year-old Roman boat was lost, and these are the artifact we recovered. This is a cup, 2,000-year-old cup. We brought it without breaking it. And another beautiful artifact, this is an oil lamp. Again, a collection of oil lamps we brought that were amazing. The archaeologists were dancing when they saw all these objects that they studied, they learned about, but never touched and never seen. Oh, by the way, we have the address in the back, and this is the address, read a Roman address in Rome. Maybe you can order through Amazon a number of those objects, I don't know. So another thing that was surprising is we were able to recover also some pieces of wood, which tell the story about the boat and where the boat was constructed, and the marine biologists were very interested. We in fact found also some kind of bacteria called iron-eating bacteria that attack the metal and make sure that there are no boats left in the bottom of the sea. So yeah, here is the robot. Another aspect of things, we think always about the hand as the solution to everything, but the truth is the hand is also the solution to carry the tool that will perform the task. The hand is amazing in carrying tools and working with those tools like we do, we human. And here we have a camera that is being carried by the robot, and this camera is taking images from areas where the robot cannot go. So then finally, the big test was to take the robot really to 1,000 meters, and we were diving off the coast of Cannes with the robot. And here is a short clip of that expedition. So in the Robotics Center, there will be a pool for the robot, a special pool equipped with the current generation and stream of water that would allow us to study further how we can deploy better the robot in the ocean. The launch of the symposium was the start of something that is so exciting to everyone here at Stanford, our students, our faculty, coming together to really take on challenges that go beyond anything that we can do in our laboratories. And this is something that is done together with in mind all the potential applications of robotics, the outreach that we are able to provide. SRC is hosting many visits every week, and this is becoming a place for the community, a place for research, and also a place for innovation that are coming out of this collaboration that is taking place here at Stanford. So this is what we call our bridge between our development and research in the area of robotics to hopefully useful real-world applications for us and for the planet. Thank you. Thank you.